So for the convenience, I am telling to you the resolving power of microscope and telescope here. So first I am telling to you about the microscope. You know, microscope is an optical instrument which is being used to magnify the smallest object nearby to us. So this is called microscope. The resolving power of microscope is defined as the reciprocal of smallest distance between the 2-point object at which they can be just seen resolved. The definition remains same. So this is the linear distance, not angular. So here d is the linear distance which is called limit of resolution. Lambda is the wavelength which is being used to see the object. 2 mu sine theta. So mu is the refractive index and 2 sine theta is called numerical aperture. So resolving power of microscope is 1 upon d, because d is the distance, limit of resolution, reciprocal of d is called resolving power. So 2 mu sine theta upon lambda is called resolving power. Both are reciprocal to each other, limit of resolution and resolving power. Lambda is the wavelength of light used. What is theta here? Theta is very important. You can observe this is the objective lens of the microscope and this is the focus, and this is called half. Theta is the half of the angle of the cone which is being formed with the help of this objective lens. Mu is the refractive index of the medium in which the object is kept. Understood? Objective lenses of the microscope is this and object in which medium they are kept. This is called mu. So this is 2 mu sine theta upon lambda is called resolving power, and lambda upon 2 mu sine theta is called limit of resolution. But in case of telescope, it is completely different. See, for convenience, this is mu sine theta is called numerical aperture. This is called numerical aperture. Resolving power of telescope is completely different. It is not linear distance. It is the angular distance which is called d theta. It is called angular distance d theta. The resolving power of telescope is defined as the reciprocal of the smallest angular separation. It is not linear separation. It is angular separation for telescope between two distant objects whose image can be seen just resolved. So that is limit of resolution d theta is called 1.22 into lambda. No derivation is there, only formula you have to remember. 1.22 into lambda upon capital D. What is capital D? And 1.22 is constant, lambda is the wavelength, this I had told you, and d theta is called angular separation. So resolving power is reciprocal of this. So 1 upon d theta is called resolving power. So it had become capital D upon 1.22 lambda. The variable, you know already, lambda is the wavelength of the light used. D is called diameter of the telescope, objective lens. Objective lens diameter. D theta is called angle subtended by two distant objects at the eye. At the eye or objective lens. So this is called d theta, angular separation. So this is all about your resolving power and limit of resolution of telescope and microscope. You have to remember these formula, very important for your numerical point of view, and sometimes they can ask you about the logical question based on this. Thank you and have a great day.